What's up, YouTubers? Jose Quiñones, the CNC Dude here. We have some motion. Check it out. This is X, Y, and the Z axis. All right. Now, I am not ready to start cutting wood yet, but I would say we have the bones of a CNC router, right? On today's video, I want to go through the different stages to finalize the Y-axis, mount the V-bore ball screw. If you have been tuning into my YouTube channel throughout the past few months, you have watched a series of videos on how to build the different implements that now make this CNC gantry system, CNC router. Those videos were 2 or 3 minutes long, very detailed in terms of each segment. Today I want to follow a different format because I figure the steps that underwent on building these parts are basically the same, right? You basically mark some metal, cut some metal, make some holes, thread some holes, welding a little bit here and there. So it wasn't like a whole lot of novel material. I did make a bunch of mistakes while building this, so that's what I'm going to go through with today's video. On a funny note, I started acquiring the parts that make up most of this CNC router on Black Friday 2022. Black Friday 2023 is going to be, not really, was about a month ago. So it has taken me over a year to build this CNC router. And I know a bunch of you might be saying, wow, a whole year to build a CNC router, you might as well just buy a CNC router. You know, I agree with that point of view. You should have just bought a freaking off-the-shelf CNC router and be done with it. Well, good call. So maybe something like this Laguna IQ that I recently acquired through the marketplace. We will be documenting this on a future video. Stay tuned. You're right, buying a CNC router is an option, but you know, the reality is that when you build your own machine, you are incredibly well equipped to service it as well. Something I have been watching on the forums is that a bunch of people that have CNC machines, anything happens and they're like freaking out. Oh my goodness, what is going on here? I don't know. If you build your machine, it doesn't matter what happens to it, you will probably know what it is. Second, if something breaks, who cares? You build the whole thing from scratch with your own hands. Whatever breaks, you just build it again. You already did it once. You can do it twice. And remember, before you build that part didn't exist. So that's some of the beauties of building your own machines. Well, let's take a look at how I built the Y-axis. So the first challenge when looking at the construction of the Y-axis is that although the sides are made from incredibly beefy 3-inch square tubing, the mounts for the stepper and the other side of the ball screw are made of flat bar. So I figure this is kind of flexible, especially considering this is almost 4 feet worth of flat bar. My impression was that this was going to flex, right? So I wanted to create braces to limit the amount of travel. So I use 1x2 channel with some coupon boards welded. My impression is this is pretty stiff now. I could be wrong, but you know, I don't think this is gonna flex a whole lot. I will know as time goes by. But very simple construction, basically 2 U channels connected, cut to length, welded the coupon boards, and then with screws they are bolted in place. So that gave me the structure that I wanted, the rigidity that I think I wanted for this monstrosity, which is almost 4 feet by 4 feet. It's actually like 38 by 38 inches. Once I had my Y-axis table rigid enough, now it was time to mount the bolt screw on the stepper. So at first I thought I'm going to reuse the same channel material to mount the BK12 ball bearing holders. Well, that didn't work very well because the size of the VK12 and the channel was not very compliant. The holes would have been almost floating. So it didn't work. Then I thought, what if I use 2 channels? And I just put them side by side, and now I have enough space for the holes. During simulation on SolidWorks, it became obvious that that would have raised the screw too much, and then it would have clashed with the table that I had in mind. So that didn't work either. At that point in time, I thought, what if I flip the U channel and cut a segment of the U channel to generate a flat U channel? Well, man, I tell you, I rigged this monstrosity to cut the channel, and that worked. It was a lot of work and a lot of metal chips, but I gotta say, I went too greedy with the welding, and I created practically a freaking crossbow. So that didn't work. At that point in time, I realized you really don't need a channel to constrain the bolt screw, because at the end of the day, you're only holding the bolt screw on the side of the motor and on the side of the other bolt bearing. So I completely disregarded the U-channel proposition. I decided to create this monstrosity clamp, 4 pieces aluminum milled to generate the clamp to mount the stepper and the VK12 bolt bearing holder. And in here is where I made the most insane amount of mistakes. Let me tell you about 2 of them. 2 cases in which I completely busted the part. I mean, it still works, but it is freaking ugly. You cannot see some of these damages because they're hidden, but unfortunately, there were some mishaps. They were both caused by me not zeroing the Z axis correctly. In the first time, I completely forgot to zero the Z axis. So of course, you know, the blade came in, woof, went through the metal. Now, there are 2 ways in which you can mess that up. You can mess it up in such a way that the blade comes down and floats in midair and does nothing. Well, Murphy doesn't say, I'm going to let you pass. Oh, no, no. I made the mistake of going the other way. And when the blade came, oh, it went. It went through the metal. The second mistake was that I did zero the tool. I remember from my first mistake, and I was like, you're not going to get me, blasted Murphy, scumbucket. Well, I zeroed the tool with the wrong tool. So of course, the offset was wrong, and once again, I could have gone to the side where nothing happens, but no, the tool went and woof, made a gigantic hole, and that's why now I have 1 screw missing. So I said I made 2 mistakes, but actually that's not true. There was a 3rd mistake. The 3rd mistake was that I, like an idiot, I made the drawing wrong, and out of 3 holes, out of 3 screws, 1 of them is misaligned. So this bracket is put together, and it's kind of okay, but it's actually missing 2 screws because of those mistakes. And 1 of them is not doing a whole lot because there is a hole that is preposterously big. But it works, okay? So I guess that's all that matters. I'm very disappointed on making those 3 stupid mistakes because they were ridiculously stupid. But man, I gotta say, if it works, that's what matters. And I know some people are gonna say, well, why don't you remake the parts? Well, it has taken me a whole year to build this machine precisely because I have like 4 to 8 hours a week of playtime. There is no way I would have had the time to redo all of this. I mean, it took me days to build these 4 parts. So unfortunately, I didn't have a chance to redo it. If I had infinite time, if my days were 25 hours long, and you know I didn't have to go to work, rest assured I would have remade the parts. All right, so once the bracket was put in place, I reproduced the same bracket on the other side for the ball bearing, but you know, it has the same holes as if I wanted to mount a stepper, but there is no stepper to be mounted, it's just a ball bearing. And then I created a socket cap to get the ball bearing really nicely. So incredibly well centered, fantastic construction. I am actually surprised, but you know, the only way you get this level of precision is if you use a really precise milling machine like the Tormac CNC 1100 to get these cuts. And even then, it's not perfect. Now, these are probably my faults. So the ball screw is mounted. Now I have to create this gigantor plate to basically extend from the ball nut into the x-axis, and we're going to grab it. All right, so here's the problem. It's very easy to find the 0 position right at the center of this gigantor plate of metal. This is flat bar, I believe 4 inches by 38 or 39, something like that. So to find the center on Y, I put it on the middle. Instead of putting it on this side, I put it on the middle. Because what you do is that you touch up, you 0, you touch up, you divide by 2, and that gives you your center on Y. Now the center on X, that for that I would need a gigantor milling machine, because there is no way I can touch up on this side and then touch up on the other. I don't have that. So what I had to do was generate a measurement and then scratch from both sides, and you know, that gave me the center. So when I put it on the Tormac, I literally took the blade up to the center, and by I put it on what I believe is the center on X. Is that the true center on X? Who knows? But the problem is, when I put this guy here, it wasn't. So the plate was longer on one side than on the other. That tells me, however, that the problem is not with the plate, but where the stepper and the ball screw ended, because I am positive this thing was way closer to center than what came up. So another issue, but not a big deal. I just shaved some material off. The only issues is basically 2 issues. One, that this plate cannot be flipped, so now I have to keep track of which one is the right and which one is the left. And the other one, that clearly that means that the stepper is not at the center, but I think the distance is not to the point where it's going to be a problem. How the heck that happened beats me. I'm not sure, because I could have sworn these things were measured to the brim, but hey, there's some fractions of an inch off. It is what it is. I'm not going to fret over it. I mean, I think this is moving good enough to where I believe that's not going to be an issue. And probably I will have to redo the 3 plates if I wanted to get it to that level of perfection. Hopefully not necessary, but we'll know as time progresses. All right, so now my plate is mounted into the ball screw, and I have to find a way to interact or interface with the actual X-axis frame. And at this point in time, I'm tinkering with little 90 angle brackets that I made out of aluminum, and I'm thinking, well, I can go up and maybe put a piece of aluminum here and grab it, but it was like incredibly tedious work, because I would have had to somehow find the perfect distances, and it was just not working as easy as I thought it was going to be. And when I mean easy, I mean hard, because it wasn't even as hard as I thought it was going to be. It was going to be way too complex. And as I'm putting all of these metals in here, it's pretty obvious that I'm going to need some sort of curve, right, to get to it. And then I was like, wait a moment, why don't I just literally take some sheet metal and curve it on the brake and make these 2 brackets? Well, I've never done anything like this before, so that was quite an undertaking. So what I did was that I took a bunch of little pieces and play with it until I got something, some profile that could work. But you know, this process is incredibly prone to error because, you know, I'm literally pushing this with my hands, so it's not possible to get exactly what you want, exactly where you want it. But it's good enough where I was able to move from the frame or from the plate into the extruded aluminum. But if you look at these two brackets, they're not identical by any stretch of the imagination. They're just what they were supposed to be for each one of these sides. So they're good enough for each side, but you cannot even flip them. So these are the kind of deals that are a little bit disappointing because you do what you can with what you have, but like if I were to manufacture this, it would be awful. So not the best, but I guess good enough. Good enough so that now my ball screw is connected to the X-axis frame, and I can move it. So there you have it, folks. We have a CNC router gantry system. There were a few challenges, but overall, I'm actually surprised. That's the word I should use. I'm surprised. You know, if you have been following this series of videos, I want to say thank you for putting up with my little madness. I do realize that CNC routers, this is not something that is like alien technology, like whoop-de-doo, this is something I've never seen before. There is probably a trillion of them out there. So thank you for staying with me throughout this build. All right, I guess that's all I have for this video. So I want to say thank you for tuning into my YouTube channel, and I'm going to see you on the next one.